Our third and last rule for undetermined coefficients deals with cosines and sines. And in particular, let's solve the following equation with initial conditions. So as usual, you first find a homogeneous solution. And for this, let's look at the auxiliary equation, which is r squared minus r equals 0. So r times r minus 1 equals 0. So r is 0, or r is 1, which gives the homogeneous solution. It's a e to the 0t, so just a, plus b e to the 1t, so b e to the t. Now, for the particular solution, the right-hand side is a cosine, and the only thing to remember is that cosine and sine are inseparable. So whenever you see cosine, you repeat everything with sine and vice versa. So step 2, particular. So the third rule for undetermined coefficients is simply cosine always goes with sine. With sine and vice versa. Vice versa. And here's what I mean by that. So here the right-hand side is cosine of 2t. Is cosine of 2t. So what you have to do, you have to guess yp to be, of course, a cosine of 2t. But the same thing with sine. So plus b sine of 2t. Or for instance, as another example, if the right-hand side, I don't know, for instance, was e to the 2t sine of 3t, then your particular solution would be, let's say, b e to the 2t sine of 3t. But because you see sine, you have to repeat that with cosine. So a e to the 2t cosine of 3t. So whenever you see cosine, repeat everything with sine. Whenever you see sine, repeat everything with cosine. And that's because they're really part of the same complex exponential. All right, so now we guessed yp to be this linear combo of sines and cosines. So now we have to plug it in. So yp double prime minus yp prime is cosine of 2t. So a cosine of 2t plus b sine of 2t double prime minus a cosine of 2t plus b sine of 2t prime equals cosine of 2t. Okay, so let's start with the right-hand side. It's a bit easier to differentiate. So using the chain rule, I think we get minus 2a sine of 2t plus 2b cosine of 2t equals cosine of 2t. And then we just have to do that again for the second derivative. So I think it becomes minus 4a cosine of 2t, and then minus 4b sine of 2t. Because sine of 2t becomes 2 cosine of 2t, which makes this 4, and then a cosine of 2t becomes minus 2 sine of 2t, which combined gives you minus 4b. And now this is like polynomials, so you have to gather around all the cosines and sines. So let's expand that out. Minus 4a cosine 2t minus 4b sine of 2t. I know, not the most exciting thing, but there'll be variation of parameters soon. So plus 2a sine of 2t minus 2b cosine of 2t equals cosine of 2t. And then if you combine everything, I think for this cosines, we get minus 4a minus 2b. And for the sines, you get minus 4b plus 2a. So this in the end becomes, so minus 4a minus 2b cosine of 2t. And then plus, I think 2a minus 4b sine of 2t. And on the other hand, we have cosine of 2t, but cosine of 2t is 1 cosine of 2t plus 0 sine of 2t. And just like for polynomials, for cosine and sine, you can just compare the coefficients. So what this tells you is minus 4a minus 2b is 1, and then 2a minus 4b is 0. But if you look at the second equation, this tells you that a is 2 times b. And if you plug that into the first equation, you get minus 4a minus 2 times, minus 4 times 2 times b. Because a is 2b. And then minus 2b is 1. And I think that simplifies to minus 10b is 1. So b is minus 1/10. And then a is 2b, which is 2 times minus 1/10. And that's minus 1/5. So what we end up getting is a is minus 1/5. And then b is minus 1/10. Which now gives you the particular solution minus 1/5 cosine of 2t, and then minus 1/10 sine of 2t. And then, as usual, for the general solution, you just add the homogeneous plus the particular solution. So you get a plus be to the t. That's what we got from step 1. And then now we have minus 1/5 cosine of 2t minus 1/10 sine of 2t. And then for sake of time, I will not do the initial conditions that you can see in the notes. Let's see the notes. But essentially what you do, you have your formula for y, you plug in t equals 0, and then differentiate and plug in t equals 0, y of 0 into, and y prime of 0 equals was minus 1. And then you end up getting, I think a is 3. And b was minus 4/5. And then in the end, we finally get our solution that y is 3 minus 4/5 e to the t minus 1/5 cosine of 2t, and then minus 1/10 sine of 2t. And if you want to see what the solution looks like, it's quite interesting because it first seems to oscillate like cosine and sine because the exponential term is very small. But then because this e to the t goes to infinity as t gets large, the solution eventually goes to minus infinity. And we will see a cool application of this in terms of oscillation and damping in the next lecture. So now what we've done, we've seen 3 rules for undetermined coefficients. exponential, polynomial, and cosine sine. And then I'll just briefly mention sums of terms, and then we'll just do one important exception to undetermined coefficients. And then we're done with all the rules.